Hello everyone. So till now we have finished Newton's first law of motion and Newton's second law of motion. Just a short recap. Newton's first law of motion gives the definition of force. Newton's second law of motion gives a method of measuring force, and Newton's third law of motion describes the forces between two objects. In other words, when two objects are in contact with each other, the force exerted by the first body on the second body is equal and opposite to the force exerted by the second body on the first body. To understand more deeply, we will see one example. Here, these are the two bodies. This is a block and this is the ground, earth surface. Here, so before that, what Newton's third law of motion states? To every action, there is equal and opposite reaction action and reaction forces act on different bodies. So this is Newton's third law of motion. To every action there is equal and opposite reaction. Action and reaction forces act on different bodies. To understand this, we'll take one example. This is a block and this is a ground. When a block is placed on the ground, kept on the ground, the block will exert force on the ground which is equal to the weight of the block. Say W, which is equal to mg. This is due to the attraction of the earth surface. Okay. Now, in return, so this is called action. When action is done, the ground will exert force on the block in the upward direction, say W dash, which is equal to mg. This is reaction. Action is the force exerted by the block on the earth, which is in downward direction. The force exerted by the ground on the earth is this reaction. This is in upward direction. So we can suppose the block is A and ground is B. So here what force is applied? FAB. FAB is the force exerted. This is this one. Force exerted by the block on the ground, and FBA is the force exerted by the earth on the ground. So I hope you have understood this, the action and reaction. So from this example, few points you should remember carefully. You should note it carefully. First thing, the action and reaction are the forces, which is F is equal to mg. First point. Second, action and reaction are acts on two bodies simultaneously. Here, in this case, block and ground are the two bodies. So, the force exerted by the ground on the block B is the reaction, and force exerted by block to the ground is the action. So, here the action and reaction are acting on two different bodies simultaneously. Then action and reaction, as I said just now, that they are acting on two different bodies, so we can't cancel the magnitude. Although the magnitudes are equal, but they are acting on two different bodies, so we just can't cancel the action and reaction magnitudes. Okay. Next thing, although the magnitudes are equal, but the acceleration which is produced will not be in equal magnitude. The acceleration produced will not be in equal magnitude. Because now the question arises, why they can't produce equal magnitude although the magnitudes of action and reaction forces are equal? Because the very big example is that these forces, the action and reaction forces, are acting on two different bodies which has different masses. Just see, the mass of the block is very small as compared to the mass of the ground. So the acceleration produced will not be in equal magnitude. So these are the few points which you should remember. Now next, I want to give you a few examples illustrating Newton's third law of motion. The first is the example of the flying of jet airplanes and rockets. The flying of jet airplanes and rockets. Suppose this is a rocket. In jet engines and rockets, the fuel is burnt to produce a large quantity of hot gases, and these hot gases come out of the nozzle with a great speed. Okay, this is coming out, hot gases, these are the hot gases coming out of the nozzle with a great speed. The equal and opposite force of the gases, moving downward pushes the rocket forward with a great force. So this is when gases are moving downward with a great speed, the rocket is going upward, and this is reaction. This is action and this is reaction. So this is one of the examples. Have you ever seen people swimming, or you might have experienced yourself? When people swim, go for swimming, what people used to do, they pushes the water in backward direction to when they are swimming with their hands, So in return, as a reaction, the water pushes the person forward with equal force. Now when we are walking, what happens? We exert force on the ground in the backward direction. The force exerts equal amount of force on our foot in the forward direction. This force exerted by the ground on the foot makes us walk. So these are the few examples which illustrates Newton's third law of motion. We have already finished the discussion of Newton's three laws of motion. Today we will talk about conservation of momentum. We have already discussed momentum. Without the explanation of momentum, Newton's second law of motion was not possible. So momentum is the product of mass and velocity. When two moving bodies collide with each other, they exert forces, action and reaction on each other. These forces changes the momentum of both the bodies which had collided. It has been found through experiments and observations that though the momentum has changed for both the bodies which had collided, the total momentum of all the bodies in a system remains constant. So, according to the law of conservation of momentum, in in the absence of an external force, the total momentum of all the bodies in a system remains constant. Constant means conserved. According to the law of conservation of momentum, in the absence of an external force, means in an isolated system, when no force is acting, the total momentum of all the bodies in a system remains constant, that is conserved. Let's take one example to see how the momentum is conserved. So, a gun and a bullet. Here, this is a gun and this is a bullet. Initially, the gun and the bullet was at rest. So, we will say the gun and bullet are at rest. So, we will write initial momentum is equal to 0. Why the initial momentum is 0? Because in the beginning the gun and the bullet both are at rest. So initial momentum is equal to 0 and kinetic energy is also equal to 0. What is kinetic energy? The energy which is possessed by an object in motion. When a body is in motion, we say it has kinetic energy. So both is equal to 0. Now, when the gun is fired, what happens? A bullet moves with a high velocity, with a very high velocity. When the gun is fired, the bullet moves with a very high velocity. So, here to conserve the momentum, what is necessary? That the momentum of the bullet when fired should be equal to the momentum of the gun. This is possible only when the gun moves with a velocity opposite, the gun moves with a velocity in the direction opposite to the bullet. Means, suppose the mass of the gun is capital M, velocity is capital V. Mass of the bullet is small m, velocity is small v. So, here the mass of the gun is quite heavy, quite large as compared to the mass of the bullet. The velocity, because the mass of the bullet, mass of the gun is high, so it will move with a very small velocity. It will move in the opposite direction. The bullet will move in this direction and the velocity of the gun will move in this direction, backward direction, which is opposite to the velocity of the bullet, and this velocity is called recoil. When so a person when fires, he gets a jerk in his shoulder because the gun will move backward with a very small velocity. So here we will see how the momentum is conserved. Here the mass of the bullet is very small, mass of the gun is very high, big. Mass of the velocity of the bullet is very high and the velocity of the gun is very small as compared to the bullet. So here both will get cancelled and will become to final momentum. Final momentum will come to 0. 0 doesn't mean no work is done. 0 means the momentum is conserved. Here when the final momentum is 0, kinetic energy kinetic energy will be very high. The kinetic energy will be very high. Now see, the initial momentum is 0, the final momentum is 0. Means when, according to the law of conservation of momentum, when the initial momentum and the final momentum are equal, then the whole momentum is conserved. So this is one of the example. Let's take the example of collision of two bodies. Without this example, the explanation of conservation of momentum is incomplete. Okay? So, we'll take two balls. Suppose this is A, this is B. Mass of ball A is m1, mass of ball B is m2. m1 is moving with velocity u1, B is moving with, m2 is moving with velocity u2. When they collided with each other, then force FAB, this is A, this is B. FAB is the force exerted by A on ball B in this direction, and this is FBA, force exerted by ball B on ball A. Here after collision, this is A, this is B, mass m1, mass m2. Started moving velocity v1 and with velocity v2. So this is the picture of the collision of two bodies. Now, as per the definition of momentum, momentum of ball A plus momentum of ball B will be equal to the initial momentum. Initial momentum will be equal to, initial momentum before collision will be equal to m1 u1 plus m2 u2. Now, similarly, final momentum of ball A and B will be equal to m1 v1 plus m2 v2. Now, let us assume that the collision took place for t seconds, for time t second. Then FAB, force exerted by ball A on ball B, will be equal to rate of change of momentum divided by t. So what is rate of change of momentum? Is equal to rate of change of momentum by time t. Rate of change of momentum will be m1 v1 minus m1 u1 divided by time t. For A to FAB will be final momentum of this minus initial momentum of this divided by, because this is rate of change of momentum. So this will be equal to m1 in bracket v1 minus u1 divided by t. Is this sentence clear to you? Rate of change of momentum means final momentum of A minus initial momentum of A. Now FBA will be equal to m2 v2 minus m1 u1 divided by t. Final momentum of B minus initial momentum of B. Sorry, this will be m2 u2. Is it clear? m2 v2, final momentum of ball B minus initial momentum of ball B. This will be equal to m2 into v2 minus u2 divided by t. As per Newton's third law of motion, action is equal to, the magnitudes are equal but they are in opposite direction. Action is equal to minus reaction. Means FAB will be equal to minus FBA. What is FAB? That is m1 into v1 minus u1 divided by t, which is equal to minus m2 into v2 minus u2 divided by t. This t will get cancelled. This will be m1 v1 minus m1 u1 is equal to minus m2 v2 minus plus m2 u2. Now we can write m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Now what is m1 u1 plus m2 u2 and what is m1 v1 plus m2 v2? This is final momentum is equal to initial momentum. Is it clear? Final momentum is equal to initial momentum means this is the law of conservation of momentum. Now, I hope this is clear to you. We'll see one more point here. Just we will recall that example which I discussed about the gun and the bullet. In that, initial momentum is equal to final momentum. Initial momentum is equal to final momentum. In that, what we got? Initial momentum is equal to 0. Initially, the gun and the bullet are at rest. So, initial momentum is equal to 0. What was the final momentum? Final momentum of the gun m into v plus m into v. This is the momentum of the gun plus momentum of the bullet. It came like this. If we will solve it, it will come like this. Now we will see what we will get. Now this small v is the velocity of the bullet. We need to find the velocity of the gun because here we use that term recoil. Means when the gun is fired, what happens? The gun will move little backward in the opposite direction of the bullet. So that velocity we need to calculate. So here we can write capital V is equal to minus mv divided by m. Is it? So here we are getting the value in negative. The negative sign here indicates that the gun is moving with a velocity which is in opposite direction of the bullet. This is called recoil. So if you will get the velocity in negative sign, in minus answer if you are getting the velocity, then don't get panic or don't get confused, because this shows that this velocity is against the velocity of the other object which is in different direction. I hope this thing is clear to you. Thank you.